Alrighty, loops and files. Decrement increment plus plus. This just kind of jumps in out of nowhere, but the thing is that in order to run a loop, very often you're counting something. The fastest way to write a little bit of code that counts something is to use plus plus. Plus plus means add one to that variable and then store it back into itself. So val is equal to val plus 1 is the same as val plus plus. That's a lot less typing. There are other advantages to doing it this way as well. Believe it or not, in some cases this is faster than this. If this is a complex data type that has the plus plus operator overloaded, words that mean basically no sense to us right now, then only having one reference to it in that line makes it run twice as fast as running that would be. You can put the plus plus before the variable or after the variable, and it does two different things. If you put it before the variable, it means plus plus happens before anything else. If you put it after the variable, then it means it's the very last thing that happens after the semicolon is executed in that line of code. Allow me to demonstrate. All right. Yet again, I have another million mains in this program. Okay, so I will zoom in. Fret not. Okay, I'm going to declare a variable a. I'm going to give it the value of 5, because I mistyped 4. Now I'm going to see out a plus plus. And then I'm going to see out the value of a again. And as a matter of fact, I'm going to see out a before any of the shenanigans happens too. So this is going to say before, and then the last one is going to say after. And then the middle one, I guess, is not going to say anything at all. Or maybe I'll just put, what are we calling this here? Postfix. This is a postfix version because the plus plus is after it. Prefix is when plus plus is before. So this is postfix. Alrighty, so when we run it, what we will see there were build errors. I've been sabotaged. Once more with feelers. All right. So, look what's happening. Compare this output, if you can read it, to this input. Probably make this slightly larger. I think I've tried this before, though. Yeah. Okay, anyways, so we set a equal to 5. So we printed a out. What did it print? Well, what do you know? It printed 5. Then we did this a plus plus, and we fed that into the stream insertion operator. So we printed postfix. It still prints 5. Why? Because if you put the plus plus after the variable, the incrementing of it doesn't actually happen until the whole line is processed. You know, like imagine that once that line is processed and that semicolon is hit, that's when the increment happens. And that makes a tangible difference in things. It may not seem like it would, but it does in this specific case. And then we print out afterwards. So after the plus plus has been executed, then a is now equal to 6. If I do the prefix version where the plus plus comes before the variable, then the plus plus is the very first thing that happens rather than the very last thing. I'm going to reset a back to 5, just so that everything is the same as it was before. But I'm going to change it so that the plus plus operator is a prefix operator, comes before the variable rather than after. Now notice the difference. The first time the variable didn't change until after the entire line was executed. So we printed out A. A was still equal to 5. But then once that print statement was done, it changed to 6. So the next time we printed it out, it became 6. But the second time, since plus plus is done as a prefix, it meant that that was done before anything else was on the line. Kind of like you do exponents first or parentheses first. This is the very first thing that happens. And so in that case, A was equal to 5, but as soon as the postfix, excuse me, that should have said prefix. As soon as the prefix plus plus was executed, that happened before it was printed out. So it became 6. In some cases, it doesn't matter. In other cases, it really does. I'll give you some examples. If I say int x is equal to 7, and then I do a is equal to x plus plus minus 2. Now this is getting kind of sloppy coding, in my opinion, because we're putting too much on one line. Why should we increment an operator and then subtract it and then store it in a different place all at the same time? But we did it. Now we're going to do that again. We're going to say x is equal to 7. A is equal to plus plus x minus 2. These give different results. The plus plus follows the variable. What is that called? Instead of prefix, it's called postfix. So this doesn't happen until the entire thing is evaluated. So what is x? It's 7. 7 minus 2 is 5. So 5 gets stored into A, and then and only then is x incremented to 6. So by the, or 8, excuse me, because it goes up, because of plus plus. So by the time we're done with this, if we print out A is 5, and x is 8. Here it's going to behave a little bit differently. X is still 7, but we have two pluses beginning it. What is that called? Instead of a postfix, it's a prefix, which means that this gets done before anything else in the line. So x turns into what? It was 7, now it's 8. And then 8 minus 2 is 6, so A is equal to 6. And x is equal to 8. If we printed them out, the difference is here A was equal to 5, because the plus plus didn't happen until after the whole thing was executed. Here it was the first thing that happened. Hope that makes sense. Quite often you see this on a line all by its lonesome. So you could do something like this. While x is less than 100, print out x and then add 1 to x. You'll often see that. And in this case, it doesn't give a bloomin' bit of difference if the plus plus follows the x or precedes it, whether it's prefix or postfix. Why? Because it's on a line by itself. So we're not using a value anywhere in that line. So it doesn't matter if that plus plus happens before we hit the semicolon or after it. So we could rewrite that to say plus plus x. But everybody does it like this, x plus plus, if it's on its own line. You know, the language is called C++. Why? Because it's a better version of C. X plus plus, add 1 to x. If we ran this out, whatever x was, it would keep adding 1 to it until x was no longer less than 100. So it printed out all the numbers between 8 and 99. If I wanted it to include 100, I would make it less than or equal to 100. There we go. So that's increment. Decrement works the same way, except it's minus minus. You can have a prefix decrement where it precedes the variable name and it gets done before anything else in that line of code happens. Or you can have a postfix decrement where you put the minus minus after the variable name and then it's the last thing that gets executed in that line of code. So the decrement operator, val minus minus, is equal to val equals val minus 1. This means subtract 1 from the value of that variable and then store it back in that variable. Plus plus and minus minus can be used in complex statements and expressions. meaning that, you could throw it into the middle of a statement like I did here. A is equal to x plus plus minus 2. You could put, all sorts of things in there. Or you can just isolate it on a line by itself if you want to just do a pure decrement and you're not using it as part of a calculation. I try not to write overly complex operations if I can get away from it. Get away with it. So if I was going to do this, a is equal to plus plus x minus 2, I would rewrite it so that it just said x plus plus on one line, and then a is equal to x minus 2. That makes real clear in what order things happen, huh? This happens before that line. Now it's the same code. It would do the same thing. If I undid those changes, it's the exact same code, but it's easier to read because it's broken out into 2 lines. The XX is supposed to be done, the plus plus x is supposed to be done first. Why not put it on a line by itself? Alrighty, here's more examples. And with the answers blatantly displayed here to make it without any challenge at all to do that. So why don't we fix that? Okay, num is equal to nothing, and val is equal to 12. So then we do cout val plus plus. What's it going to print? It's going to print 12. And then what is val equal to after that line is executed and it's reached a semicolon? 13, because it's been incremented. Right. So printed 12, and then val is equal to 13. Now we're going to do the opposite. We're going to do a prefix. What's it going to print? Well, val is equal to 13 here. The plus plus is in front of the variable, so it's the very first thing to happen. So 13 changes into 14. So it both prints out 14, and then val is equal to 14 at that point. Now we're going to decrement. Is the decrement going to happen before the operation or after the operation? It's going to happen before. So val is going to turn to 13, and then it's going to get copied into num. So num is equal to 13, and so is val. How about here? Is the minus minus going to happen before the statement is executed or after? Okay, so val is equal to 13. 13 gets copied into num, so num is equal to 13. Now the statement's done and it gets decremented to 12. Hope that makes sense. You can kind of see some test questions coming up, based on that. Just because we have to test over something, huh? And why are we talking about these now rather than when we were talking about math? It's because these are very useful for loops, and this is the chapter on loops. So plus plus can be used in expressions, kind of like that. That looks pretty goofy. Again, this is something I would not write because it's kind of hard to read. Num plus plus, space minus minus, blah. You can use it in a relational expression. If plus plus num is greater than limit, that means add 1 to num, store it back into num, and then compare it to limit. So introduction to loops, the while loop. We've used these off and on. Now we're being introduced formally. Pleased to meet you, Mr. Loop. Loop, a control structure that causes a statement or series block of code, block of statements to repeat. The general format is the while keyword, and then inside the parentheses is some conditional expression that evaluates the true or false. And then there'll be either a single statement or a block of code surrounded by curly braces. As long as this expression is true, statement will continue. And it's pretty easy to mess up and write infinite loops doing that. Or you can write a loop that looks like an infinite loop, but it really isn't. I'll give you an example of each one of them. Okay, so suppose I come and do this. While x is less than 200, print x. Looks great, except I'm not modifying the value of x. So x will never stop being less than 200. If I run it, it's going to be an infinite loop, which just means, yay. Don't really want that to happen. But if I put a break statement in here for some reason, I mean not for some reason, if I put a break statement in here, I can get it to leave the loop. I'm going to give an example of that. I'm going to just make it say while x is greater than 1, x plus plus, and then see out x. That should run almost forever. Because, x is always going to be greater than 1 until we exceed the limit of the variable, which is like 8 billion or something like that. But we could do this. If x is equal to 500, break. The break statement causes it to leave the loop early. It stops looping. It comes down to the brace that matches the opening brace underneath the while statement. So in this case, it's only going to print out up to 500, even though it looks like an infinite loop or a nearly infinite loop. I could, if I make it while true, that would make it go forever, except I provided a way out with a break statement. Start debugging, it's going to print, and it's going to go all the way to 500. It hit the break statement, so it exited the loop, so it did not continue going forever. So quite often, you'll see me write code that says while true. That just means keep repeating until you hit a break statement, rather than base it on some variable. Here we're basing it on a variable. But sometimes I find the logic easier to write if we just say, okay, it's a given that we're going to keep looping until we hit a break statement. And since you saw while true, you know that somewhere in there is going to be a way to exit, to break out of the loop. So the way it works, we've kind of already made this clear. As long as this expression is true, we keep repeating this statement. It's like an if statement, except an if statement only performs that statement once, if this is true. While continues to repeat that, and it will continue to repeat it as long as the expression is true. The logic. Yeah. If expression is true, it does the statement, and then it repeats over and over and over until expression is no longer true. Something needs to update this expression, or else you have an infinite loop, unless you're going to provide a break statement on some special case. Here's our example. This program demonstrates a simple while loop. We're going to print out hello 5 times in a row. So we initialize a variable number equal to 1. And then we say while number is less than or equal to 5, print out the word hello. Then add 1 to number. So the first time we go into it, number is equal to 1. Is 1 less than or equal to 5? Sure enough, so prints hello. Then we add 1 to number. Number is now equal to 2. It comes back up to the while statement. Is 2 less than 5? Yep. So prints hello. Adds 1 to it. Number is equal to 3. 3 less than 5? Indeed. Add 1. Print out hello the third time. Add 1 to it. Now it's 4. Is 4 less than or equal to 5? Yep. Print out hello. Add 1 to it. Now number is equal to 5. 5 less than or equal to 5? Yep, but this is probably the last time through the loop. Print out hello the 5th and final time. Add 1 to number. Number is now equal to 6. Is 6 less than equal to 5? Nope. So it breaks out of the loop and it prints that's all. Here is how this author chose to flowchart this. When I do this kind of flowchart, I don't only put a decision box, I actually put the word while, so that you know whether this is a while or an if. So I would say while number is less than or equal to 5, print hello, and then I would put number plus plus. Why use the word add 1 to number if I could actually use the notation plus plus? Now your flowchart's not supposed to be specific to any one language, but all programmers who've taken a programming course or looked at the C language or anything like that know what plus plus means, because it's used in a lot of other languages as well. And it would keep repeating this over and over and over until number was no longer less than or equal to 5. And when that was true, it would break out of the loop and execute whatever was underneath, whatever was next. So the loop must contain code that makes the expression become false. Otherwise, the loop will have no way of stopping. But I've told you to cheat to that. Issue a break statement. Such a loop is called an infinite loop because it will repeat an infinite number of times. Will it really? No. Eventually, you'll stop the program or turn off the computer. But, theoretically. There we go. Int number is equal to 1. While number is less than or equal to 5, print hello. It's going to print hello until we kill the program, because nothing ever changes number. And there's no break statement to get us out of there. All right, using the while loop for input validation. You want them to enter a number, and you want to make sure that it's a valid number. You can use a while loop to force them to keep typing numbers in until they get it right. Input validation is the process of inspecting data that is given to the program and determining whether it is valid. So a while loop can be used to create input routines that reject invalid data. The general approach in pseudocode: read an item of input. While the input is invalid, display an error message, read the input again. We can do that. So, cout. Please enter a positive integer. Maybe we're going to take the square root of it or something. Who knows? Now we're going to store that as input. So I'm going to declare a variable, I for integer. I is equal, or cn into I. And I'm going to test it. Is this really valid data? Well, for it to be a positive integer, how do I check to see if it's a positive integer? How could I write an if statement that would check to see if it was true? I would say if I is what? Somebody's awake. Well, I'm not going to do modulus because I'm just checking to make sure it's positive. And what does positive mean? Greater than 0. Okay. Then I could print out an error message. But instead, I want it to be a while loop because I don't want them to be able to enter any data or to exit this code until they've given in and finally entered good data. So if I is less than or equal to 0, it means they entered a negative value. And I'm going to display an error message. This is not a positive integer. You know, and then if I was really nice, I could explain what a positive integer is. You know, enter a value larger than 0. And now I ask for it again. Cn into I. This will not let them. Now let's take the square root of it or something. I'm going to include cmath, so I get the square root function. Excuse me, I get the POW function. I'm sure I also get the square root function. There we go. Okay, I'm just doing this so that we had some reason of getting a positive value. Taking the square root of a negative number, you get something called an imaginary number. I'm not even sure what C would do in that case. Might be fun to try out. Okay, and then we're going to print out the square root is, and let's print out sqrt of that number we just read. Okay. Now this has got a bunch of garbage in it that's good. It's going to run before it actually gets to input statement. Here we go. Enter a positive integer. If I press 1, it works. The square root of 1 is 1. Yippee. Now let's do it again, but we're going to give it some bad input. 0. That is not a positive integer. Please enter a value larger than 0. Now I'm mentally challenged, so I'm going to type in -1. It still says this is not a positive integer. All right, -100. This is not a positive integer. Okay, I get tired of playing this game, and I finally type in 2 or something, and it says what the square root of 2 is.
Are we running signed data types right now?
Yeah.
We are. Sorry, I wasn't. I should have.
Yeah, if I made I an unsigned int, I don't even know what it would equal when I typed it in. Let's find out. The difference between an assigned and an unsigned number is that an unsigned number can be larger because it uses that first bit.
If it's unsigned, wouldn't it return a positive value that is congruent to the negative value modulo the maximum?
Let's find out. I'm going to type in -1, and it says the square root is 65536. So that's exactly what it did.
Sorry, I was just curious. I was like, well, that seems odd.
Okay, we're going to take that unsigned away. An unsigned number can never be negative. Why would you want to use an unsigned integer? Because you get twice as many more values possible to store in it. So that is how you can write a routine that will make them enter a valid value. Now there's something I don't like about this particular method. And what I don't like about it is it requires what's known as a priming read. It has to do this once, and then this code is repeated here. We have two different lines in the code that get input. I would rather find a way of jiggering this while loop so that we only had one line of input. And to do that, I would use a break statement. Here's how I would rewrite this code to only require reading in once. I would say, please enter a positive data. I'm going to declare a different integer now, x. And then I would say, while true. I'm going to make this look like an infinite loop. I'm going to ask them to enter the integer, or I'm going to let them type it in with CIN. Now I'm going to check. If CIN is greater than 0, it's valid data, so I may as well break out. Else print, this is not a positive integer. Enter a value larger than 0. And since we didn't break out, it's going to loop while x is greater than 0. So do you see the difference between what we did before and this? This one does not have what's known as a priming read. We did not have a CIN statement before the while loop and then inside the while loop as well. We only have one CIN statement, it's inside the loop. And if we get valid data, we break the loop. Otherwise, we print out an error message. It's forced to come back here, and they get a second shot, a third shot, a fourth shot at entering it. The expense of doing this conceptually is that our logic became a little bit more complicated because we added an if statement inside our while loop. Go away. Here, we read our input, and then we entered a while loop, but the while loop only executes if the data is wrong. So there's no if statement in the middle. Which way you like to do it is up to you. I like to do it the other way, because I like to have my input only focused in one command rather than in two different places. It's up to you. Both of these are totally valid code. So I'm going to denote that this is the same code, but written to not require a priming read. A priming read is input done before the while loop that validates the input. So this is our priming read here. We printed enter a positive number, we asked them for input, then we entered our while loop. We had to prime it in order for our while loop to work. Here we ignored that, we just did while true. As long as we have invalid data, we're going to keep looping over and over until they type in something good. If they type in something good, we're going to break. Slightly different concepts. Functionally, they're identical. Code-wise, I like the way this one looks. If you don't like putting an if statement inside your while, all right, that's belaboring that enough. Input validation. Here's our, please enter a number less than 10. While number is greater than 10, print invalid data. Please enter a number less than 10. So this has our priming read, just like I was talking about. They ask for the input, and if the input is correct, the code does not enter the while loop. Because if number is not greater than or equal to 10, it'll just skip all the while loop entirely. Here we go, read the first value. Is the value invalid? If it is, do some stuff in a loop, come back and do it again. Check to see if it's valid now. If it finally is, then we bail out of the while loop. That's input validation in a flowchart form. Counters. A counter is a variable that's incremented or decremented each time the loop repeats. It can also be known as the loop control variable. It can also even be known as the iterator. Hey, let's give it a lot of different names to make it confusing. Counter, it's counting. 1, 2, 3, 4, 5. Loop control variable. Why is it called that? Because it controls the loop. Once it finally exceeds a certain value, you're going to exit the loop. Iterator. Why would you call it an iterator? Because, it keeps incrementing each time. But counter and loop control variable are the words to remember. You have to initialize it before entering the loop, because if you don't give it an initial value, then you can't check it with while. Here's their example. They declare a constant called min number. They set it equal to 1. They declare a constant called max number. They set it equal to 10. And then they have a counter called num. This is going to span 2 pages. So first they print out, I hate it when they do that. Here's the rest of the code. While the number is less than or equal to the max number, print it out followed by its square. And then increment the counter. I'm going to type that in so that we can see it. Okay. So const int min value is equal to 1. We're going to start counting at 1. Const int max value is equal to 15. Let's go up all the way to 15. And an int num, that's going to be our counter, is equal to min value. We're going to start our counter there because you have to initialize it to something before your while loop. While num is less than or equal to the max value, print out the number, print out the word squared is, and then print out POW of num to the power of 2, followed by an end of line. This will print all the squares of 1 to 15. Heck, I'm going to go out 1 to 16 because I know 16 squared is 256. Let's do that. Does not work. Build errors. X redefinition. Alrighty. I'd already defined X somewhere else, so I can't do that. But we could give it a starting value, you know, like X is equal to 0. Whatever. Okay. Back to the meat of it. Our counting loop. Please enter a positive integer. Okay, fine. 1. Please enter a positive integer. 1. Now I'm getting too much. Oh, and look at that. It's printing 1 squared as 1 over and over and over. What did I forget to do? Did I hear it? What's wrong with my code here? I'm never increasing num. So I could do this, num plus plus, right there. Now it's good. I need to get rid of all this other code. All right. So 1 squared is 1, 2 squared is 4, 16 squared is 256. So here's a loop controlled counter. This is our loop control variable. That's our counter variable. It goes from the minimum to the maximum. Why did we declare these as constants? Just to make them look awesome? Well, you know. Now we know where to change them. If this code was separated a long way away from this, you know, or if this code is repeated several times, then it's nice to only have to define it in one place. We may later decide that we want to handle numbers larger than 16. We might go out to 256. We would only need to change it in one place, no matter how many times we had while loops that counted out the max value if we define it as a constant. All right, there we go. 256 squared is 65536. It printed out 256 different square values, going from 1, counting 2, 3, 4, all the way up to that one. So this is a good example of a loop control variable. You can also do the same thing with a for statement. And I like the syntax of for statements better. It looks like this. You give it a starting value. Num is equal to min value. Then you give it a comparison. Num is less than or equal to max value. And then you tell it how you want it to be incremented. Num is plus plus. And then you could print out num squared is that. Okay, so the difference in our loops is this. This is using a while loop to count from 1 to 256 or whatever max value is. This is using a for loop to count from minimum to maximum, incrementing by 1 each time. To do this one, you have to remember 3 things. You have to remember to initialize the value, you have to remember to put a conditional in, and then you have to remember to put the update in. I always forget to do the update. I wind up with an infinite loop the first time I run it. A for loop makes it very simple because you put the initializing statement here inside the parentheses, separated by a semicolon from the conditional, that's the second line, and then the increment. And this increment happens after the body is executed. So the way this works, it sets num equal to 1. It checks, is it less than the maximum value? It sure is. It goes ahead and prints out. It hits this closing brace, so it adds 1 to num, and then the conditional is checked again. So now num is equal to 2. Is 2 less than our max value? It sure is. Print it out, hit the end brace, add 1 to it. It's now 3. Is 3 less than max value? Eventually, num will no longer be less than or equal to max value. So that's the difference in syntax. You have 2 different loops available to you. You have while and you have for. You have a third kind of loop, but these are the ones I'm talking about right now. The for loop is just more concise. There's nothing you can do with a for loop that you can't also do with a while loop, or vice versa. It's just more concise syntax. Maybe this looks more complicated because it has a lot of stuff on the top line, but it's not really. And once you get used to using it, it makes for cleaner code. You never forget to add your increment because it's part of the header of the for loop. It's right there. The do-while loop. The do-while is a post-test loop. It executes the loop and then it tests the expression. All right, gang. I'm tired of lecturing and letting y'all space out. I'm going to make y'all type if you weren't before. Go ahead and launch Visual Studio. Make a new project. And we're just going to write 3 different kind of loops. No pre.
What's the title for this?
What in class are we at?
H was the last one.
All right, this will be in class I. Oh, by the way, for everybody who their version of Visual Studio has expired, I put a note on D2L about what you need to do, and I'll also demonstrate it here. You just need to get your registration key into it. Okay, so the very top of the code, I'm going to do include IO stream. I'm also going to tack on include string and include CMath, just in case I want to do something with strings or with math like POW or square root later. Then I'm going to delete this T main and replace it with main. There we go. Now I'm ready. Okay, I'm going to write a while loop. The way a while loop works is it's known as a pretest loop because your condition is up at the top, like an if statement. If that condition is not true, it won't even go into the loop. So here we go. X is equal to 1. I better declare it. Int x. X is equal to 1. While x is less than or equal to 100, print out x followed by an end of line and an x plus plus. Semicolon. Add 1 to x. And then I'm going to print out something, print out another end of line just to put a blank line between that and our next output. All right, now I'm going to write a for loop. For int y is equal to 1, y is less than or equal to 100, y plus plus, C out y end L, and then C out end of L at the end of that loop. So this will count from 1 to 100 2 times in a row. First time using a while loop, the second time using a for loop. After we get this working, we're going to write one more loop, which is a do while loop, and we're going to compare what that means as opposed to a while loop. Let me make sure it works. I better run it. Okay, yeah. It printed 1 to 100 2 times in a row, so I'm happy. I'm going to try to get this all to fit on one page, so I'm going to move some curly braces around. Makes it harder to read, but at least I get the whole thing on one page. There we go. Right. So you see the difference between a while loop and a for loop. They're exactly the same thing in a different syntax. You specify a starting position, just like you initialize a variable here. You specify a condition in the conditional expression. As long as that's true, the loop keeps running. And then you specify an increment. And on a for loop, you can leave any of these things out. If you don't feel like initializing a variable, you just don't put anything before that semicolon. If you don't feel like incrementing your variable, you leave that y++ off. If you don't feel like having a condition, you leave the condition off, and it's the same thing as doing a while true. Now, usually, if you're going to use a for statement, you're going to fill in all three things, but you don't have to.
You just put the semicolons there instead.
Yeah, you just have to put the semicolons there as placeholder. Bring your binoculars.
Yes. Try it.
Anybody getting mysterious syntax errors they need help bashing?
Which one did you say? X equals 1? No, it'll initialize and start at 1. It'll run it as 1.
Yeah.
And then if you put ++y, it would.
Yeah, that's what I'm saying. Put ++y goes
Plus y would work just as well as y++ in this case. Why? Because it's isolated on a line all by itself. So it doesn't matter whether, the plus happens before or after it hits the semicolon in that line. It doesn't matter whether it's prefix or postfix. All right, if we've all got this working, I'm going to go ahead and space it out again. There, I'm going to put my braces on their own lines. I'm going to add some white space to make it easier to read. Now I'm feeling good about it. Okay, the difference between a while loop and a do while loop. This is a pretest loop. I'm going to add a comment to it. It's called pretest because the test condition occurs before the loop. We check to see if this condition is true, and if it is, then that code is executed. If this condition was false, we would never execute that code. Let me give you an example of when that might be false. I'm going to copy and paste that code. You don't necessarily have to do this, but if you want your notes to match exactly mine, I'm going to make x equal 1,000 here. And then while x is less than or equal to 100, how many times is it going to print out anything there? Is it going to print it out once? Is it going to print it out none? It's never going to print it out. The reason being is because this is like an if statement. Since this part isn't true, it's never going to enter the body of the code. Because this is a pretest loop. This is tested before the body of the code. A do while loop is not tested until the end of the code. So that would look like this. X is equal to 1,000. Do some stuff. I'm cutting and pasting, so I'm going to be going a lot faster than y'all. Sorry about that. I'll chill out in just a second. All right. Here we go. We don't do any testing until the loop is already executed, because this is post-test. Okay, I'm going to add something stupid to the cout statement to make it blatantly sure that we know that we're going to get here or not. I'm going to output the word wowzers followed by X. And then for the do loop, I'm going to print out the word neato, because I'm really enthusiastic about this. Okay, so how many times am I going to see the word wowzers? Well, the test condition is false, so is it ever going to enter the while loop? Somebody wheezed out a no. Okay, good. I heard one. Okay, So this loop code will be skipped entirely. What about this time? X is equal to 1,000. Do this. Well, there's nothing stopping us from entering the loop. So it goes ahead and prints Nito 1,000. Then it adds 1 to Nito. Nito is now equal to 1,001. And then we hit the condition, while X is less than 100. Well, is X less than 100? No. What is it equal to at that point? Yeah, it's equal to 1,001. So it stops the loop that way. You use a do loop if you want the body of the code to be executed at least one time. Use a while loop if it's okay for the loop to not be executed at all if the condition is not true. I hope that's real clear. If the test comes after the body of the code, then the body of the code is going to be... Oh, I need a semicolon here for this to actually compile. So if you were trying to get this to compile, I apologize. I'll have to semicolon off. There we go. It didn't print wowzers because that was a pretest loop, but it did print Nito. That's pretest versus post-test. A do loop is a post-test loop. A while loop is a pretest loop.
Is it supposed to print Nito 1,000?
Exactly, because X equaled 1,000.
Oh.
So it printed Nito followed by the number 1,000. It added 1 to 1,000 to become 1,001. And then we did our check. Is 1,001 less than 100? No, it's not, so it falls out of the loop. Here we didn't even print wowzers because we checked at the beginning. It didn't even get into the barn, you know.
So do while is basically like a for loop that's initialized with a value starting at 1. Or sorry, initialized with a...
A while loop and a for loop are exactly the same. A do loop is different because if the condition is false, it still executes at least once, and that's not true for a for loop.
Right. I just mean you could do the same job if you...
You could almost always use them interchangeably if you're giving it valid values that are going to enter the loop. But if you give it a weird value like that, a weird starting value, then you hit that edge case where you might execute it in one case and not execute it in the other. All right, so the do loop, the loop always executes at least once, unlike a while loop where it might not execute at all. Execution continues as long as the expression is true. The for loop, I've already talked about for loops, so this is going to be real fast. The syntax for a for loop is the for keyword followed by parentheses. Inside the parentheses, you have 3 things separated by 2 semicolons. The first thing is the initialization step. The second is the test condition. The third is the update. All of those are optional, and you just still have to leave the parentheses as a placeholder. If you don't feel like initializing your variable, you don't have to. I'll give you an example of that. What if we decide that we're going to write a for loop that's going to count up to 10,000? Maybe I don't want to reinitialize x, so I could just leave it blank. And then I could do x is less than or equal to 10,000, x plus plus, and then I might print out x, like that. I left out the initializing statement there because there was no reason to initialize it. I'd already decided that it was going to equal a good value by that time, and if it didn't, then it wouldn't go into the loop, just like a while loop. Or if I was going to use a break statement to execute it rather than this test condition, I could leave that part off. That's getting kind of weird. But it's not hard to understand, it's just weird. So for loop mechanics, it performs the initialization first. Then it evaluates the test. If the test is true, it runs the statement or block. Once a statement or block is done, then it does the update. So that's kind of deceptive. This update being up here makes it look like it's the first thing that happens, huh? But really, it doesn't happen until the statement is run. And that's to make it work exactly like a while loop, where you do while, condition, perform statement, and then you do x plus plus or whatever. Once that update has been done, the test condition is checked again. And as long as it's true, it keeps repeating the statement followed by the update. All right, what can you use for loops for? What can you use while loops for? You can use them for all sorts of things, but I want you to commit this code to memory. How to use these loops to calculate the sum of a series of values, or how to use a loop in order to calculate the product of a series of values. So let's say that I'm going to use that min value and max value idea again. Looks like we're in new code, so that's okay. Int min is equal to, I want to count all the numbers between 1 and 100. Int max is equal to 100. While, and I need a counter. Why not I just use x? We've already used x before. X is equal to 0. While x, no, not x is equal to 0, x is equal to minimum. It's the starting point. Okay, that's cool. While x is less than or equal to the max, we need a sum variable, and I have not declared it yet. I'm going to go ahead and use it here. Sum plus equals x. But I better go and define it. So above or below where I declared int min and int max, I need to declare int sum is equal to 0. So I just added that, guys. I forgot to add that before. Sorry. All right, now I may as well print out my results. I could either give out a lot of input, or I could just say sum is, followed by the sum variable and E and DL. It doesn't tell you our range. It'd be nice if we gave them the range. So I'm going to tack on, no I'm not. I want it to be as simple as possible. There we go. That would add up all the numbers between 1 and 100. Why does that work? Because we started sum at 0. I'm going to copy this code, but I'm going to make it times equals rather than plus equals, so that we could calculate the product of all the numbers in a range. And it's actually going to be an error, and I'm going to ask you for help in correcting it. So again, let's set min equal to 1. Let's set max equal to 10. We're going to multiply all the numbers between 1 and 10. It's not called a sum anymore, it's called a product because we're doing multiplication. I'm going to set that equal to 0. I'm going to initialize my counter equal to min. I'm going to have my while loop while x is less than or equal to max. Product times equals x. Multiply the product by x and then store it back in a product. And then let's print out the product. Product is followed by the product variable. I'm going to test this and run it, and then I'm just going to leave it on screen for a minute because I know I type fast. Oh, neat. I have an infinite loop. Yet again. What did I do wrong? Whenever you hit an infinite loop, what's the likely cause of it? You're forgetting to update your counter variable. So both of my while loops, I'm forgetting to update the counter variable. What do I need to add to fix them? X++.
Where did you add that?
I put X++ at the end of each of my 2 while loops. Because without it, it's just an infinite loop. Okay, if you manage to get all this typed in, run it and tell me what the product is. And why would that be?
I have build errors.
That's also a plausible answer. Think about why product is equal to 0 rather than a valid value. Because 1 times 2 times 3 times 4 times whatever should not be 0. Missing a semicolon. What line number does it say that's on? Double click on that and it should go to line 51. the semicolon after your while statement.
Did you say that you liked apple pie?
That's exactly what
There we go.
Dude, I like apple pie.
Anybody figure out why product is equal to 0?
Only one that likes it.
product starts out at 0.
Liar, John.
Yeah, because if you're going to multiply all the numbers between 1 and 10, you don't want to start at 0, because what's 0 times 1? 0 times 2 times 3 times blah, blah, blah. Okay, so in order to make this code actually work, we need to start product at 1. So that's just kind of a parenthetical note. When calculating products, set your accumulator variable, your product, to 1. When calculating sums, set your sum to 0 before starting. All right, who's getting weird syntax errors? I need to scroll up, I need to scroll down. Like that? Okay. You could simplify this code considerably by leaving off this min and this max declaration. It could just be x is equal to 1, x is less than or equal to 10, you know. How are we doing? Any syntax error? Oh,
I'm just trying to figure out if I'm on the right section. If I'm reading the right part of my page. I have not gotten a lot of sleep in the last 2 days.
I'm gonna help you.
I'll figure it out. I'm just trying.
We need to take this stuff and rip it out of this 4y is equal to 1 out to 100 stuff.
Okay.
So I'm gonna yank all that and push it there.
Oh, cool.
Alright.
Thanks.
Now it's not indented right, but otherwise it was gonna repeat this code 1,000 times.
I would have caught it eventually.
Yeah.
Yeah. Thank you. It's alright.
No problem. Are we all good? I see about 15 phones in people's hands, so I expect that y'all are done.
What's it supposed to get for the product?
To fix the product, you have to set it equal to 1 rather than
What was
0.
it supposed to get?
Pardon me?
Just as I was asking, what was it supposed to get?
Oh, probably, oh gosh, I can't remember. Is it 50-50? Yeah, 50-50, 5,050.
Some,
Oh, the sum is 50-50, the product is 3 million and something. And there are cute little mathematical formulas you can use to calculate those without actually having to iterate through them. And I don't know. Yes, sir, Solomon.
I wonder if you could go back to the false, to the beginning.
Which part? Oh, you want to see the for loop? Okay. All right, guys, we've covered loops and incrementers pretty well. That's pretty much all we need to know about looping, except to actually write some programs that use loops. And I haven't created a, there's our loop statement. Is that the one you're looking for?
No, the one right prior to the wow statement. With the mean.
That one right there?
And the max false, yeah.
Okay. So we're pretty much done. I'll make a Dropbox for this. Wednesday, we'll actually use loops for something more useful than just counting and adding and summing. And we'll make a homework assignment for them as well. And Sarah, did you get the telephone digit program finished?
Oh,
Okay, cool.
yeah.
All right, gang. Refresh your Dropbox. You'll see Dropbox I. Upload your CPP there. And we'll call our turkey done.
Also, you have